So far, all semester, we have been using rectangular coordinates, which is what you are familiar with, where all of our variables have been x and y. If the variables are r and theta, then you have a polar equation. So what you are seeing here are just some examples of polar equations, things like r equals 3 times sine theta, or theta equals 5 pi over 6, or r equals theta. Notice that the only variables that we have in these are the letter r and theta. You are going to be asked to graph polar equations. And so what I have given you here is just basic examples of polar equations. In the upper left, r equals a. Well, think about r stands for radius. So if the radius is always some number, then that's going to be a circle. If you have theta equals some number a, then that will be a line at an angle, and that angle will depend on what your a equals. A equals r cosine theta. If you think about that, cosine theta we talked about was always the x coordinate. And if you have an equation in rectangular form that is only x equals, that is always a vertical line. So when you are in polar form, if you have only cosine, you have only x, so it's a vertical line. Conversely, the sine equation, if you have r sine theta equals a, because sine is y, that will always be a horizontal line. Just like y equals 3 is a horizontal line in rectangular coordinates. On example 11, we are asked to graph the following, and our first graph that we want to do is r equals 3. Remember what we said about r, that's radius. So if you want to graph an equation that is just r equals 3, from the very center, you go out 1, 2, 3, and then you want all of the 3, so it will be a circle at the third line from the center. On B, we are asked to graph theta equals 3 pi over 4. In your polar graphing system, you can see that 3 pi over 4 is over here. So when you are graphing this, you go to 3 pi over 4 and you graph that line, and you continue into the quadrant opposite and go all the way through to the 7 pi over 4. You graph all the way across the circle. Once you find your original angle, you go all the way across the circle. To graph an equation like r cosine theta equals 3, remember we talked about that if it's cosine, it's the x coordinate, so it is a vertical line. You want a vertical line at 3, and we're going to go to the right because it's positive from the center of the circle. So here's 1, 2, 3 lines. That's where we want our line to be, and we need it to be vertical through that 3. So there is r cosine theta equals 3. For r sine theta equals -1, we want a horizontal line that is 1 below the center. So it's right in here. There's your 1 that's below the center. Now you want a horizontal line through that. Just pretend my line is actually straight. And that is the graph of r sine theta equals -1. The next thing we are going to look at is graphing complex numbers. In order to graph a complex number, we change the way we think about the rectangular coordinate system. Instead of having the x be the horizontal axis and the y being the vertical axis, the real part of the complex number is the horizontal axis and the imaginary part is the vertical axis. On example 12, we're going to graph the imaginary numbers that we are given here. It's probably been a little while since you dealt with complex numbers, so let's do a little bit of a refresher here. This is the real part, and the I is the imaginary part. So when you are graphing these, the real part is the horizontal. So you go right or left, whatever the real number is. The vertical is the imaginary part. So you go up or down the imaginary value. So point A, because the real part is 4, we're going to go right 4. The imaginary part is I, which is just one I, so you go up 1. So that is point A. For point B, the real part is -2, so we're going to go left 2. The imaginary part is 5i, so we'll go up 5. For point C, we're going to go right 6 and down 2. It's important to know where complex numbers lie because we are going to be converting between trigonometric numbers and complex numbers. And so you have to know what quadrant the numbers lie in. On example 13, we are going to convert between rectangular and trigonometric numbers. The numbers that we are going to be given are trigonometric, and we have to convert them to rectangular or complex form. So when we look at numbers like a, 2 times the quantity of the cosine of 300 plus I times the sine of 300. Our unit circle is going to come back into play, and we are just going to substitute the sine and the cosine of 300 in those parentheses. So we keep the 2 out front. In our parentheses, the cosine of 300 degrees is 1/2. So we're going to replace cosine of 300 with 1/2 plus I times the sine of 300 degrees is negative square root of 3 over 2. To complete our problem, we distribute the 2 to both terms, and 2 times 1/2 gives us 1. 2 times negative square root of 3 over 2 leaves us with just the negative square root of 3 times I. You can choose to write this as 1 minus square root of 3 times I. For example B, the only thing that's different is that our angles are in radians, and that is absolutely fine. The process does not change. So we're going to keep the 10 on the front. We are going to substitute what cosine of 3 pi over 4 equals. It equals negative square root of 2 over 2 plus I times the sine of 3 pi over 4 is positive square root of 2 over 2. Now distribute your 10. If you do that, you will get negative 5 square root of 2 plus 5 square root of 2 times I. On C, what's a little bit different is that instead of writing cosine individually and sine individually, they've used a shorthand version of these numbers, which is the CIS form of it. So what you need to recognize about this is that this is equal to having the 3 out front, and then inside your parentheses you have the cosine of 150 degrees plus I times the sine of 150 degrees. Now the problem is exactly like the others. So we're going to have 3 times cosine of 150 is negative square root of 3 over 2 plus I times the sine of 150 is 1/2. Distribute your 3, you're going to get negative 3 square root of 3 over 2 plus 3 times 1/2 is 3/2 I. For D, we are doing the square root of 2 cis 225. So remember that this is now the square root of 2 times the cosine of 225 plus I times the sine of 225. So replacing our values, cosine of 225 is negative square root of 2 over 2 plus I sine of 225 is also negative square root of 2 over 2. Now, when we distribute this, we will get negative square root of 4 over 2 plus negative square root of 4 over 2 times I. Negative square root of 4 is the same thing as negative 2. Negative 2 over 2 gives me negative 1. We could write plus a negative, or you can just write minus 1I. Or if you want to, you can just write this as negative 1 minus I. They are the same thing. Now we're going to look at going the other way, where we will be given a complex number in the form of x plus yi, and we are going to turn it into polar or trigonometric form. So we're going to use the idea that x equals r cosine theta, y equals r sine theta, r equals the square root of x squared plus y squared, and tangent of theta equals y over x. If you substitute r cosine theta and r sine theta for the x and the y in x plus yi, then you get r cosine theta plus r sine theta times I. But then if you factor out the r, you get r times the quantity cosine theta plus I sine theta, or we sometimes write this as r cis theta. So the complex number of x plus yi is the same thing as the trigonometric or polar number of r cosine theta plus I sine theta. On example 14, we are going to convert complex numbers to trigonometric or polar numbers. The first thing we want to do is look at our number and decide what quadrant would it fall in. If you look at this, we have 1 plus square root of 3i. Well, the 1 would have us go right, and the square root of 3, because it's positive, would have us go up. If you go right and up, you are in quadrant 1. So that's the first thing we got to recognize. Now, the x is the real part, so the x is the 1. The y is the number in the imaginary part, so it's the square root of 3. Now that we know what x and y equal, we can find r, because r equals the square root of x squared plus y squared. Remember, r is our radius, and so we're just doing a Pythagorean theorem here. So in our problem, we're going to have 1 squared plus the square root of 3 squared, but that gives us 1 plus 3, so we get the square root of 4, which is 2. So now we know x, y, and r. And the last thing we want to do is think about our tangent of theta. Tangent of our angle. What this will let us do is figure out our angle. The tangent is y over x. It's the square root of 3 over 1, which just equals the square root of 3. Either way is fine. It doesn't matter which way you choose to think about it. So what we have to think about is in quadrant 1, this is what you're asking yourself. In quadrant 1, what angle has tangent equal the square root of 3, or the square root of 3 over 1? That's what you're looking for. So looking at the unit circle in quadrant 1, we now know that the theta that we have to be talking about is pi over 3. Now that we know theta and we know r, we are ready to go to trigonometric form. When you go to your trigonometric form, the r you found goes out front. Inside, you start with cosine and then do the theta you just found, pi over 3, plus I times the sine of pi over 3. Now remember that this could be written as 2 cis of pi over 3. For example B, the number that we are given is 3 minus 3i in complex form. So if we think about that number and what quadrant it falls in, if we go right 3 and down 3, we are in quadrant 4. Our x value is 3. Our y value is negative 3. We need this so that we can find r. r is the square root of x, 3 squared, plus y, negative 3 squared. We're going to have the square root of 9 plus 9, which gives us the square root of 18. And then we need to simplify that. That becomes 3 square root of 2. For our theta, the tangent of our theta is y over x, so we're going to put negative 3 over positive 3, so our tangent is negative 1. We want to know, in quadrant 4, what angle has tangent equal negative 1. That's what we're looking for. So in quadrant 4, the angle where tangent is negative 1 is 7 pi over 4. So now, once you know r and theta, you are ready to actually write your number. This means that the trig version of this number would be 3 square root of 2 times cosine of the angle, 7 pi over 4, plus I times the sine of the angle, 7 pi over 4. You can write that in cis version if you'd like. Our last example is the complex number, which is just 4i. If you think about the number 4i, that means that the real part is 0. You can think of this as being 0 plus 4i. If you were going to graph that and the real part is 0, then you stay on the y-axis and just go up 4. So the graph of this complex number is on the y-axis, the positive y-axis. Well, because you are on the positive y-axis, think about that. What angle is on the positive y-axis? That angle has to be pi over 2. There's no choice. There's no figuring on this one as to what angle it's going to be. We do need to find r. Our x is 0, our y is 4, so r is the square root of 0 squared plus 4 squared, which is the square root of 16, which is 4. So the trig version of this number would be 4 times cosine of pi over 2 plus I times the sine of pi over 2. The next thing we are going to look at is multiplying trigonometric numbers. So if you have two trigonometric numbers that you are supposed to multiply, you multiply the r values and then you add the angle values on the cosine and the sine. If we want to multiply these two trigonometric numbers, we multiply the r's. So we do 3 times 2. Then we start with cosine and add the two angle measures, 45 plus 135, plus I. Now do the same thing on sine. Add the two angle measures, 45 plus 135. So multiply your r's, you get 6, and then you get the cosine of 180 plus I times the sine of 180. The process does not change when the numbers are written in cis form. So the r's are 4 and 5. We're going to take 4 times 5. We are going to have the cosine of 120 plus 30 plus I times the sine of 120 plus 30. Our product then is 20 cosine of 150 plus I sine of 150. When you are dividing two trigonometric numbers, you do the quotient of the r's. Take r1 divided by r2, and then you subtract the angle measures for the cosine and the sine. For example 16, we are going to find the quotients, and then we are given two trigonometric numbers. Our process is to take the two r's, so we're going to take 10 divided by 5. You divide the two r's. In your brackets, you are going to do the cosine of negative 60 minus 150 plus I times the sine of negative 60 minus 150. So our quotient then is 2 times the cosine of negative 210. And we're just putting parentheses around the negative 210 for readability purposes. Plus I sine of negative 210. Doing the quotient on these two numbers, we will take our 127 divided by R2 of 9. Then we will have the cosine of 45 minus negative 180 plus I times the sine of 45 minus negative 180. 27 divided by 9 is 3. Cosine, add those angles, you will get 225 plus I times the sine of 225.